சரி இது மைக்ரோசாஃப்ட் Good afternoon to everyone present here. Am I audible? Okay. We'll move on to the session. First, I'll introduce myself. Myself, Kanishk. So I just completed my undergraduate from Panimal Institute of Technology, and I'm also currently pursuing a BS Data Science and Applications from IIT Madras. Currently, I'm working as a AML specialist at Prodapt. So we'll move on to the session. So AI applications in manufacturing and smart factories. So everyone should have an idea about smart factories, what smart factories are, like automobile industries, where they use both technologies and also hardwares to produce products like anything from medicines to smart industries. They use AI in every field today. So we'll move on to the session. So these days factories were like just the machines needed to do repeated work, but nowadays factories need machines to think. Everyone should have an idea on what when I say that machines need to think. It is nothing but AI, machine learning or deep learning, where we train models to make machines think. So, as I said, in the past, the factories were only about the machines doing repeated work, repeated hard work instead of humans. But here, AI comes in its place. So, for example, let's say there is automobile industries where it produce cars. And what if a AI model predicts when does the machine gets breakdown or machine gets failure? So it is what AI does. So this is not a science fiction anymore, and it is happening right now, and that is what takes us from Industry 4.0 to Industry 5.0. So what's the main difference between Industry 4.0 and Industry 5.0? So Industry 4.0 was mainly focused on automation, IoT, and smart systems. So it is nothing but automated machines, which works without the guidance of humans, like the AI systems, machine learning. So, for example, you could say in applications like unmanned drones. So it works without the guidance of humans. And here comes Industry 5.0, which focus on human-centric and sustainable manufacturing. It is nothing but where a human and also a model works together instead of only a model working on its own. It works under the guidance of a human. So that is was the main idea of Industry 5.0. So moving into the topic predictive maintenance. Does anyone have idea about predictive maintenance? What is predictive maintenance? Yeah, exactly. So these days we are following traditional maintenance. It is nothing but if a machine is working, we will repair it or we will modify to other machine only if any breakdown or failure occurs. But predictive maintenance is it uses AI to predict the failure. So, for example, let's consider in a BMW plant. Everyone know BMW cars. So AI analyzes data from the machines and predicts from the past failures and says like this machine is going to be breakdown or failure at this particular time or this particular day. It considers millions of cost and it is efficient and very optimizing. It is what predictive maintenance is. What is AI in quality control? What is quality control? So quality control is nothing but so if I'm making a product, making a phone, so we would have seen in reels or some discovery channels like there will be persons who are monitoring the products after the complete after the product is made. So instead of a human eye, how it would be if an AI model monitors it? Yeah, it is what quality control. So for the real-time application is Foxconn. Everyone knows Foxconn, which is the supplier for Apple iPhone. So Foxconn is the supplier for Apple iPhone. It uses AI-powered cameras to scan each iPhone's part to detect any microscopic flaws, and if it detects the microscopic flaws, it rejects the product. So it is what AI in quality control. So it has better accuracy than humans. Yeah, actually. In this quality control, AI has a better accuracy than humans. So next is process optimization. What is process optimization? So let's start by saying a application. So let's say a smart factory produces around 100 widgets of goods of any product. Let's say 100 iPhones. So the sensors monitors the data like the temperature, pressure, or more there will be more parameters like temperature, pressure, size, anything. So it monitors all the data, all the parameters, and checks for the best parameters where it is more efficient and more optimizing. So what are the parameters that represents optimization or like energy usage, supply chain performance, producing resources more than the previous produced resources. Like let's say if for 1 month they are producing 100 iPhones, and for the next month their goal would be if they perform process optimization, if they perform process optimization correctly, they can also reach the goal of producing 120 iPhones per month. So it can increase the profit and it would be more efficient. Yeah. So the real-time application is Siemens uses its Amberg plant, where 75% of production process are automated and self-optimized based on the past data. So there are so many algorithms like heuristic algorithms, which says the best, what is the best cost, and also AI algorithms like grid search. So these are used for process optimization. Yeah. So human AI collaboration. This is what I was speaking about the Industry 5.0. So cobots. What is cobots? So it is nothing but robots which work with humans. So yeah, let's say does everyone know what is Power BI? Yeah. Yeah. Power BI is a tool for creating dashboards, reports, and visualizations. Yeah. So, does any institutions or managements teach Power BI in their institutions or colleges? I feel like it's a no. Yeah. So it's a software where we use it for data analytics or data visualization to create dashboards. Now, how Power BI is, we can give a single prompt to Copilot and creates a whole dashboard. So how is it? Instead of a person creating a whole dashboard manually, the AI creates the whole dashboard. It's like we give a prompt to ChatGPT. So create a dashboard on this data. This is the data. Give four insights on the data. So it creates the whole dashboard on its own. We don't have to do any work. So, but the thing is, we can't publish the dashboard directly after the creation through AI. There should be a human guidance, should check the dashboard and to do any corrections if needed, and then the dashboard can be published. So, this is what I say is human AI collaboration. And also, can anyone? I think so. Everyone will watch movies this generation. So, can anyone give example of any science fiction movies like where a human and a AI collaboration is made? Yeah, Endiran. Yeah, someone is giving answer as Endiran. Yeah. And also, I think so. Everyone knows about Iron Man. Iron Man, Marvel. So it is also a human AI collaboration. So Iron Man and Tony Stark. So he is a human and Iron Man is a AI. So both collaborate to form Iron Man. So this is what human AI collaboration is. And also there's a quote in the presentation: AI is not taking jobs; it's transforming them. Yeah, it is what actually mean. Actually, AI can't replace humans. That is what I can say. It is a step to upgrade humans' knowledge and thinking. Yeah. So what these are the basic tools and technologies used in AI in predictive maintenance, quality control, or process optimization. Basically, we use machine learning models. So SkyKit is the library for ML models, and TensorFlow we can create neural networks. And these are the platforms. I think so. Those who attended the last session would have known it. AWS and Azure ML, IBM Watson, and most commonly we use VS Code for it. So what's next? As a passed out graduate, I feel like the students in the students in the curriculum, I feel like most of them have gotten no exposure to creating ML models, like using real time data. Some of them you create ML pipelines, yeah, but they don't use the real data, they just use the clean data from Kaggle. But what is happening in real time is the data will be the data won't be cleaned. There will be a large process to clean the data. For example, I would say, for example, we can say there are alerts coming like DB storage full, and like so many alerts are coming, connection issue, agent issue, like that. So these are classifications of more alerts. So if there is a human who need to classify the alerts, so if there are four humans working to classify the alerts, so there will be a in and error occurs there. So what is the possibility of error is that four humans may classify the same alert differently. So the same alert will be coming to the four humans. For example, let's say ABC is the alert. So four humans will classify the alert. One will classify as DB issue, one will classify as connection issue, like that. So this is the thing happening if there is a human error. So for how Industry 5.0 can give a solution to it. So ML models can be created using logistic regression or a KNN. So it classifies the alarm based on the trained data, and also there can be a human. Instead of four humans, there can be a one human. So it reduces the cost and it increases the efficiency and optimization. So the human can get, if the model MN model classifies any alarm as wrongly, the human can correct it. So it increases the overall efficiency and accuracy of the model. So yeah, so in today's world, AI is about, there is no need to do the grunt work. So grunt work is nothing but doing the whole coding for the application. The AI does it all. But what a human needs to do is he needs to be creative. So AI can't think very creatively as a human does, because human has a brain. It's very complex and it's very beautiful. So only human can think creatively than AI. So what an AI can does is, so with the creativity of humans, using AI together under the guidance of humans, we can create wonderful applications, wonderful softwares with the creativity of AI, instead of avoiding the grunt work which the AI does. If you ask an AI to code an application after giving an idea, like say example you want a application like YouTube. So YouTube is a creativity. So, but the AI codes the whole YouTube. So that is the grunt work. So what I say is humans need to be creative. They need to upgrade themselves to sustain in the field of AI. Yeah, that's it from the theory session. Now we'll move on to the hands-on. So we'll see some two models which are used in smart factories, like a real-time application. So yeah, I will share. I will share a collab file in the WhatsApp group. So I request everyone to download the collab file and open it in Google Colab. If anyone have any issues, they can. Yeah, guys, I will shared the file in your group. So the IP1 by file is the notebook we will access in Google Colab. So what I want you to do is download the two CSV files and the IPONB file, and go to Google Colab. Uh, we'll wait for 2 minutes to upload the file in Google Colab. I think so. Everyone would have uploaded the file in Google Colab. So let me share my screen and show you how to do it. I think so. My screen is visible. So I want you people to open Google Colab. So I want you to give new notebook, and after that, there will be an option like in files. There will be an option upload notebook, and then browse, and then upload the downloaded IPONB file there. Now the file IPNB file is uploaded. We'll wait for 2 minutes. Now I can upload the data sets. So I shared you two data sets, which is predictive maintenance data set and stored factory lags. And I want you to upload those two. So how to do is here we'll have this folder file thing. By clicking that, we will see the upload files symbol here. So now you can upload the downloaded CSV files here. Now the files are uploaded. I think so. Everyone would have uploaded and followed the same process of what I did. Can anyone let me know if someone is facing any issue in the chat box or through voice? Guys, can anyone let me know if they want any, if they're facing any issues, or I'll move on to the next, or should I give the instructions again? Okay, guys, I will repeat the process again. So you have to open a Google Colab just by searching in Chrome. You will open it. So and you have to give new notebook. You can see it there. After that, here you can see the file option. In that, you will see upload notebook, and you should give browse. You should upload the recently downloaded IPONB file which I sent in the group. Yeah, now the IPONB file is uploaded. Now I want you to upload the data set. So let's wait for 2 minutes to connect. Sure, ma'am. So now we'll upload the CSV files in the Colab. So here we will see a file symbol. So by clicking that, we will see a file upload option. After that, I wanted to upload the CSV files which I shared in the group now. I think so. Everyone would have followed the process and upload the data set. Now we'll move on to the next part. So I want you to first, can you see this run button or play button here? Okay. Can everyone see this play button? I want you to click on the play button. It is nothing but we are running the code cell. Click on this play button, guys. So it will run this code cell. If you guys face any issue, let me know. Sorry for the interruption, guys. So I want you to run the next cell. So after running this first cell, I want you guys to run the next cell. Before that, so this is the data set we are using, which is predictive maintenance data set. So I want you guys to click on the predictive maintenance data set and see these are the values. So the parameters we are having are temperature, vibration, pressure, humidity, and failure. So zeros are ones are, like zero is no failure has happened, and one is where the failure has happened. So we are using this data set to train our model. So basically, what's the goal of this model is, based on the readings of the parameters like the temperature, vibration, pressure, and humidity, we are going to predict the failure before it happens. before it actually happens. So these are the data captured by the sensors of the machine. So we are going to train the model using this data, and we are going to predict the failure before it is going to happen. So it is called predictive maintenance, as we saw in the PPT. So I think so everyone would have run the second cell, and there will be output. There will be a plot shown. So what this plot is saying is that, so everyone can see that blue and yellow or orange. So this blue are the parameters or values where no failure has happened, and yellow is the parameters or the values where failure has occurred. So basically, this is called a data visualization. From the data, we can visualize that yellow is the failure. Yellow is where the failure has happened. So we can see that the values of yellow is a bit higher comparative to blue. The temperature value is also a bit higher. Vibration is also a bit higher than blue. Pressure is also a bit higher than blue, and humidity is also higher than blue. So from this visualization, we can just theoretically conclude that if there is a higher value or higher parameters of humidity, pressure, temperature, or vibration, the machine is frequently failing. And then I want you to run the next cell. So this is the basic machine learning pipeline. So first, we are loading the data set, and this is called a exploratory data analysis, which is nothing but using the data, we would transform it to visualize it. Just by visualization, we could just conclude some points theoretically, like what we did now. And next, we are splitting the data. So basically, in machine learning, you split the data like training and testing data. So there would be like we split the data like 70-30 or 80-20. If there is a large amount of data, we will use 70-30. If there is very less data, we will use 80-20. So 80% for training and 20% for testing. So now we can run the third cell. So this is the classification report. So I think so everyone would know what accuracy is. So if you are asking 10 questions or giving 10 inputs, it should predict the 10 inputs correctly. So if it predicts the 10 inputs correctly, the accuracy is 100. So it is what it's saying. It's 1. And future importance. What is future importance? So we are using these 4 features: vibration, temperature, pressure, and humidity. So for this particular model, vibration is the most contributing feature for the output. So how we are getting the future importance is, so we are using a random forest model. So it is a tree model in machine learning. So while training, it captures the future importance values. So based on that, we can say that vibration is contributing more to the output. So if the output is 0 or 1, like the failure is happened or not, vibration is the parameter which is contributing more to the output, to the failure. So and then I want you to next run the next cell, which is step 8. Yeah. So now we are going to give the input, and we are going to test does it correctly predicts the output or not. So first, I think so it will ask the value for temperature. So just click on the data set. Let's take any value. Like we will take the third row. So where failure has happened, you can see here the failure has happened. So I will say the values. You guys just enter. For temperature, enter 84. For temperature, enter 84. And next it will ask for vibration. Enter 1.2 or something. any value 1.2, 1.3 like that. And next it will ask for pressure. So enter the value 6. And next it will ask for humidity. Enter the value 60. I think so. It will predict it has a failure occurred. Failure occurred. Let me try. Yeah, the machine is likely to fail. So this is how predictive maintenance is done. So the sensors record the data on a daily basis or a real time in real time. So this data will be sent in real time to the machine learning model, and it predicts if the failure occurs in beforehand, so that we can reduce the loss which will happen if a machine is breaking down or if a machine is failed. So because of this, we can increase the efficiency and also the optimization of the model and the process we are working in. So this is the ML, just a basic application for predictive maintenance. Does anyone have any questions or based on this model? If not, we will move on to the next model. I think so. Anyone does anyone have any questions to ask? Or else we'll move to the next model. So if you want to enter the input values again, you can again run that particular cell, and you can enter. Yeah, I have shared the code for this data is already in the group, in the WhatsApp group. I shared it in the WhatsApp group. You can access the IPNB file in the WhatsApp group, and the dataset is also in the WhatsApp group. So guys, can we move on to the next model? So we are moving on to the chatbot, which is a RAG chatbot. Does anyone have any idea about RAG? What is RAG? So yeah, RAG is nothing but a retrieval augmented generation. So how the RAG's architecture goes is, so let's say we have a CSV file let's say we have some data. So we are converting those data into embeddings. So embeddings are like numerical values. So if I say my name is Kanishk, so we convert this data, we convert this sentence into embeddings, which is like numerical values. Using there will be many models, embedding models to convert the data into embeddings. So this that sentence will be converted into embeddings, and we store that embeddings to a vector DB, a DB called vector DB. So basically, many of them will use Milvis. So Milvis is a vector DB which is widely used by many software or IT companies or any smart industries, smart factories. So, but for free of use, like Milvis is we need subscription for it. But Fias, which is Facebook AI search, it is also a vector DB of created by Facebook. So we are using Fias here. So we are storing that vector values in the Fias DB, and we are retrieving the values. So for example, I ask what is my name. So it converts this question into embeddings and search for the embeddings nearest distance in the vector DB. So let's say the question is converted to into some embeddings, and we have also uploaded some embeddings in the vector DB, and it checks for the nearest distance between the question and the data in the answer. So and it retrieves the data which is of nearest distance to the asked question. So and then we are after retrieving the data from the vector DB, we are giving it to the LLM. So I think so. Everyone should know about LLMs. So LLM is nothing but ChatGPT, Gemini, Claude, Anthropic, like that. We are we are using that. Sorry for the interruption, guys. So yeah. So after retrieving the output from the vector DB, we are giving, so the output will be just like Kanishk. So what is my name? The output we retrieve will be just like Kanishk, but it should be in a natural language or a full completed sentence. So we are giving the output to a LLM. So let me just show the prompt for the. So this is the prompt we are giving. Answer the question based on the following logs. So logs are nothing but the retrieved data from the vector DB. So can you see the prompt here? Answer the question based on the following logs. Like the prompt we give to any LLM like ChatGPT or Gemini, we are using that in our code. So this is how we use LLMs in our code. So and then by giving that retrieved data to the LLM, it gives the output in a full structured format, like a full natural language in a full sentence instead of just the data. So let's run this code. We will get a. So guys, I just want you to run this. Install all these required libraries. So just run this cell. It will automatically install the required libraries. So. Uh, so it will take 2 minutes. So yeah, so it will take some time, guys. So we'll have some break for 10 minutes and we'll continue by 2:40. Yeah, guys. The session will be continued by 2:40, guys, because the libraries are installing. So it will take some time. So we'll continue by 2:40. I want everyone to install the libraries.
அட்டனை போட்டுறேன், அரவுண்ட் ராப்டர் போட்டுறேன்.
We'll start in a few minutes, guys. Yeah, we'll resume the session, guys. So before the break, I told you to install these libraries just by clicking this run button. I hope so everyone would have installed these libraries. After installing the libraries, I want you to just export the dataset by, so now we are using the stored factory logs. So by clicking on this dataset, we can explore this dataset. So what are the parameters in this dataset? So we have the timestamp and the machine and the event. What is the event occurred, like the failure, inspection, maintenance, like that. And we have the vibration value and the technician who worked on the machine and the remarks. So what happened to the machine, why the failure occurred. So these are the logs, these are the data we are going to use now for our RAG model. I think so everyone is clear on the data set. So these are the logs. So now, as before I said, run this first cell. I want you guys to run this first cell where the data is loading. Yeah. Now the first, after running the first cell, what we are doing in the second cell is, so for a RAG model, we can't upload a data like in a structured format. We can also upload, but for this particular use case, what we are doing is we are converting this whole data set into a sentence. So M2 failure, event failure, vibration 1.5, and technician Mohit, and the remarks motor overrated. So we are converting this whole data, whole structured rows into a sentence. Why? I will let you know why we are doing that. Why? Because we convert those whole, instead of converting a structured data into embeddings, it is useful and it is good to convert a single sentence into embeddings and store it in the DB. So we are converting it into a whole sentence, and we are converting into embeddings using a sentence transformer. So it is a basic embedding model where we will use it for conversion of the text to embeddings. So I want you to run this cell so that this text, the data is showed, will be converted into embeddings. So let me print that embeddings. So it will look something like this. So this is for each sentence. The embeddings will be like this. So these embeddings will be stored in the vector DB like this. And what will happen is, if we ask a question, so I will show you the question. So these are the questions. Who? Let's take this question. Who performed the last inspection for machine 1? So these questions are converted into embeddings again. So it will be converted to something like this, and it compares both the questions and the data's embeddings and checks for the nearest distance and retrieves the data which is the nearest distance to the asked question. So this is the embeddings, and now we are storing those embeddings in a FIAS DB. So this is FIAS. So it is a vector DB. So open source vector DB. So basically, as I said before, most of the tech companies like Google, Microsoft, any company use Milvis as its vector DB. We use FIAS because it's open source. So yeah. So we are using the LLM. We are using Google Flan T5. So it is a basic free version and open source model. So if you want to use ChatGPT 4o Mini, we need to subscribe for it. So you can use any model for it. So if you use better models with subscription, it will give better answer as per the model's capability. So we are using this model here. So now we will test this model by asking the questions. So as I said before, this is the prompt you are giving to the LLM model. So here we are retrieving top three. So here top k is 3. So it is nothing but from the vector DB, which is the FIAS DB, we are retrieving the top 3 similar data to the question we asked. So we are retrieving the top 3 data, and we are using the top 3 data and we are sending it to the LLM. So the LLM will give the answer in a structured format in a natural language. So we will see how it gives. So these are some 10 questions we have asked to the RAG model. So this is how the chatbot is created, the basic chatbot with the data. Like for example, the other applications are like, so if we have the doctors use some books, medical textbooks or medical any references, they every time they need to refer anything from the book. They can't just study the whole book. So what we can do is we can convert those whole, we can perform RAG on that. we can convert this whole book into a embeddings and upload the embeddings, the vectors to the vector DB as we do here, and we can ask questions to that as we are going to do here now. So let's see what are the answers it is going to give for the questions. So the first question is which machines had overheating issues? So these are the data we had in the logs. So based on the data, we can say that machine 2 and machine 5 had overheating issues. So the question 2 is when was the last maintenance for machine 3? So the last maintenance for machine 3 was on 25/6 and 01. So who performed the last inspection for machine 1, machine M1? So it gives the answer as Ravi. Which machines have high vibration levels? So from this we can see that machine M3 has high vibration levels. So it is retrieving that machine M3 and giving us the answer. So this is what RAG is. So it retrieves the data from the vector DB and it sends to the LLM and it gives the answer based on the context we are generating from the vector DB. So for every question, it gives the answer by retrieving these logs. So why you are seeing 3 logs here is the top K is 3 here. So if you modify it to 5 and run it again, so it will take the top 5 logs. So as we can see it now, it takes the top 5 logs. So if we take the top 5 logs, now we can see the data set, the more data has expanded, and we can see more range of machines now. So which machines had overheating issues? It says M2, M5, and M3. So when was the last maintenance for machine M3? Yeah, it's the same. So like this. So based on our data, if we feel like if the top K is 10, then the RAG model will perform better. We can take the top K as 10. So based on the data, we can modify the top K. So to increase the performance of our model. So yeah, guys, that's it from the hands-on. So that's if anyone have any questions to ask, they can proceed. Any questions? Any doubts? So basically, finally, how we can conclude is that, as I said before, okay, about RAG. Vijay Lakshmi SS has to, okay. So I will repeat about RAG again. So basically, what RAG is, it is retrieval augmented generation. So what it does is, let's say, for in simpler terms, let's say we have a data. So we have any PDF, you have any textbook, you have it in PDF format or any file format. So you have a textbook. So you are converting those content in the textbook to embeddings. So embeddings are like numerical values. So it will be something like this. So if we convert those content in the textbook to embeddings, it will be something like this. So these numerical values are calculated based on the dimension of the sentence or dimension of the word, like that. So after converting those content to embeddings, so for converting the content to embeddings, we use a sentence. I mean, there are so many embedding models. So there are even paid embedding models. So like there is a Azure OpenAI model, which is embedding model. So we need subscription for it. So, but this sentence transformer is a free open source model. So, if we use some paid models like with more cost, it may perform better. Like it may convert this content into better embeddings. So we are just using a open source model. So we are converting the content of the textbook to embeddings. So embeddings is nothing but okay, let me share my screen. Sorry. I think so my screen is visible now. So these are the embeddings I was speaking about. So if we convert the content in the document in the book to embeddings, it will look something like this. So after that, we are storing these embeddings. So this other, it is also called as vectors. So we are storing these vectors in the vector DB. So there are so many vector DBs. So most commonly known vector DBs are like Milvus. So Milvus is a paid DB. So we should subscribe for it. So we don't we most of the top companies like Google, Microsoft, most of the companies like Google and Microsoft use a Milvus as the vector DB. So we are using Fias. So Fias is Facebook's open source DB, vector DB. So we are storing the vectors in the DB. So basically, we are converting the content of some contents, some data into embeddings, and we are storing the embeddings in a DB. So we should store the embedding somewhere. So we are storing it in the vector DB. So after that, what we are doing is we can retrieve the data by asking the questions. So how it is happening is, so this is the questions we are asking. What it does is it converts these questions to embeddings, like how it is done here. So it will also, the questions will also something similar to it. So it will compare the distance between both these data in the vector DB and in the questions asked. So if the distance is near or lesser to the data and questions, so it retrieves the data which is similar to the question asked. So we can retrieve top 3, top 5, top 10 like that. So based on our data, based on our understanding of our model. So after after retrieving the data from the vector DB, so it won't be good just like if I ask what is my name. If I do, it won't be good if it just returns Kanishk or something like that. It should be in a proper natural language. So for that we are using it in for using a we are using an LLM. So LLM is like a chat GPT or Gemini. So we are using that in a code process, in a code flow. So we are using this open source LLM of Google's, which is Flan T5 base. So here we can use OpenAI's 4O Mini, which is ChatGPT 4O Mini, which is a paid model. So as I said, paid models may perform better than this open source model, which can give better accuracy and efficiency also. So after that, as I said before, we are retrieving the top 3. I mean, here we are retrieving top 5. You can also retrieve top 3 or anything you want based on our use case. So here we are retrieving top 5, and then we are giving it to the LLM. So here it is the prompt we are giving it to the LLM. So answer the question based on the following logs. So logs are the data we are retrieving from the vector DB. So and the question is the questions asked there. So which machines had overeating issues. So we will have the top 5 logs from the vector DB retrieved from the vector DB, and we will give it to the LLM, and it answers and it gives the output based on the questions asked. So we can see how it works now. So these are the 10 questions. So you can ask any question based on your data. You can query your data in natural language. So you can see what are the answers it is giving. So for the first question, which machines had overeating issues? So we are retrieving this. Our top K is 5. So we are retrieving top 5 data from the vector DB. So from this, we can see that M2, M5, and M3 machines had overeating issues. So, and for the next question, when was the last maintenance of machine M1? I mean, sorry, where is that? Machine M3. So you can see that its answer is 25, 6, and 01. So like this, it retrieves any questions you ask it, and it retrieves the top K from the data of vector DB, and from that the LLM gives a precise or a proper answer, a full formed answer. So this is what RAG is. I think so. You guys understood. Does anyone have any questions? Guys, if anyone has have any questions based on ML models or RAG, anything like that, or else if not, you can end this call today. Okay, guys. Thank you, guys. That's it from my session. Thank you everyone for attending the session.